Okay, so this is the last video, part 3, to finish off the 8.2 notes page. And it's looking here at the end at just this notion of how you would, if you were planning a study, how you would decide what sample size you should take if you were trying to have a certain confidence level and you wanted your margin of error to be a certain amount. Okay, so it says here, in planning a study, you might want to choose a sample size that allows you to estimate a population proportion with a given margin of error by plugging in the desired margin of error, the desired confidence level, which is our z-score, and the known p-hat into the margin of error formula. Okay, so here you can see this part here on the right is really the part that we know gives us the margin of error. Okay. So it mentions here, let's suppose that we want to create a 95% confidence interval to estimate, say, the true proportion of people in the woodlands that are Democratic. And we want our answer to have a margin of error of 3%. Okay, so in other words, we want our point estimate to be within 3% of the true proportion 95% of the time. Okay, so the question is, how many people should we survey? Okay, well, the problem is, we can easily calculate if we're going to do a 95% confidence interval. We know we would type in something, like this on the calculator to get the z-score, okay? And the z-score would be this 1.96. Okay, we know what we want the margin of error. The issue is we don't know the sample proportion, and we don't know the sample size. That's what we're trying to figure out. What should be the sample size? So we kind of have too many variables because we don't know p-hat and we don't know n. Okay, so there's kind of two ways to handle this. Okay, one way is you could guess what p-hat would be based on just kind of looking at previous studies maybe that have been done over this particular topic. The way that we're going to do this is we're going to choose a p-hat value, which might sound kind of weird that we're just kind of guessing what a sample proportion would be, but we're going to make our guess super conservative. Okay, the guess that you're going to use is you're always going to use 0.5. Okay, and the reason we're going to use 0.5 is because if you use 0.5 for p-hat, this maximizes the product of p-hat and 1 minus p-hat, okay? Which, if you look back up here, okay, that's this part right here, okay? 0.5 times 0.5, that's the biggest possible number that could be, okay? And what that's going to do is that's going to make this the absolute most conservative way of kind of going about this. Okay, so let me just give you an example. We'll walk through one so you can kind of see how this looks. It says find the sample size required if you are wanting to do a 95% confidence interval to estimate the true proportion of people in the woodlands that are Democratic. And you are saying, look, this is what I want my margin of error to be. I want it to be within 3% of the true parameter, okay? So what you're going to do is you're only going to take this part up here, okay? This is what represents the margin of error, okay, that part of the formula, okay? And we're going to calculate our z-score real quick, which we've done this multiple times, but the z-score for a 95% confidence interval is going to be 1.96, okay? So that's my z-score, because we know that's part of the margin of error, okay? And then here, keep in mind, the goal is to figure out what n should be. So that's the only variable that we want, okay? We are picking a very conservative p-hat value. 0.5 is p-hat, and then, of course, this part is supposed to be 1 minus p-hat, which would also be 0.5, okay? And that's deliberate here, okay? Now, we want the margin of error to be within 3%, okay? So that means I want it to be less than or equal to 3%, okay? And honestly, from here, you're just using basic algebra skills to solve this for n, okay? So what I'm going to do is I'm going to take the 1.96, okay? Essentially, what we have underneath the numerator of this square root is we have 0.5 squared, okay? So if you are going to take the square root of 0.5 squared, that's going to just give you 0.5 in the numerator, okay? And the denominator, we still have a square root symbol over top of the n, okay? I'm just going to pull that n that's in the bottom here, kind of like doing something like this, so get it over in the numerator, okay? And I'm going to divide both sides by 0.03 so that we just have the square root of n on that side, okay? And that leaves us with, for solving for n, we would then square the square root of n, so the n's by itself, and essentially we would type all this into the calculator to get an answer initially of 1067.11. Okay? Now you always want to round up, okay? So this means our sample size should be 1068 or greater. And if we do that, we should be able to maintain the confidence interval that we're creating to be within 3% margin of error, okay? Confidence interval, 95%, okay? So I'm going to try another one here with you, okay? Next page, example 6. Once again, you're going to notice nowhere in here do they give you the sample proportion. Obviously, we don't have that because we're trying to figure out how many people we should survey. If we haven't surveyed the people yet, we don't actually have a sample proportion, and so we're picking a really conservative value here to plug in, okay? So up here at the top, I've just got our general formula. It says for your AP Stat end of the year project, you want to estimate the proportion of students in the upper school that like math. You want your estimate to be within 4% of the true proportion with a, this is different, a 96% confidence interval. So let's real quick just calculate what that z-score critical value would look like for a 96% confidence interval. Okay, if we type that in, it looks like that's going to come out to be 2.05. Okay, so I'm looking back up here at the top here. I'm going to plug 2.05 in for the z-score. I'm choosing 0.5 for p-hat, which in turn makes 1 minus p-hat 0.5 as well. The goal is to solve for n. I want to get what my sample size should be. And I want the margin of error to be within 4%. So it needs to be less than or equal to 0.04. Okay, and again, this rest of this process is identical. Numbers are just different from the previous example we did. Okay, so you can just kind of use your algebra skills to kind of manipulate this a little bit to get the, oops, the n by itself. Okay, I guess right here we could say we're going to square both sides. Okay, and that's going to give us n has to be greater than or equal to. Initially, we get a decimal. Always, I'm going to make this note here, always round up. Okay, when you round up, as n increases, your margin of error will decrease. Okay, so we always want to round up. We see that if we want to have it with these constraints, we need to make sure that we're surveying at least 657 students. Okay? Okay, so the last example in this notes page is really what part B is to that free response question, number 5, back on the 2011 AP test. And this is exactly like the previous two that we did. This was talking about the flu vaccine from the previous video that you had watched. And so I just already worked this one out here because it is quite literally the same thing that we had done, just some different numbers. Okay, this is just a 99% confidence interval. That's why you see I've used the z-score that correlates with that. Okay, and the question wants us to figure out how many people we should survey to keep the margin of error less than or equal to 0.02. Okay, so you can see I got it set up there. I'm just manipulating this using algebra to kind of get the n by itself. End up initially getting n is greater than or equal to 4,160.25, but we always round up. So we're saying we should survey at least 4,161 people to have these constraints. Okay? I have seen several problems that are like this, where they ask you what the sample size should be for these proportions. The part you want to remember is always use 0.5 for p hat when you're doing this. Okay? All right, this is the last video, so the close here. Okay? And this should be the end of the notes page here, and you should be good to go kind of go ahead and work on the assignment that goes with this section. All right, feel free to message me if you guys have any questions at all. Thanks.